Hi guys, it's Jay again, and I'm back with another Rainmeter video. So on the previous video I went through the components that I bought, the applications I downloaded in order to create a DIY hardware monitor using Rainmeter, HWiNFO and the HWiNFO Rainmeter plugin. And after that video was published, a few people expressed an interest in seeing my code and how I managed to actually create my skin. So this video is going to be mainly geared towards those who have shown interest from the previous video, and I'll be doing a deep dive into each section I've written, and I'll be explaining basically line by line what each little bit does. And I'll also be doing some changes as well along the way, just to show you what each bit does as an example, and so on and so forth. So if you haven't watched the previous video yet, I'd highly recommend you go back and watch the previous video. I'll probably highlight it somewhere in the comments or in the description, or have like a little tab or something just visible on screen for you to go watch it. Mainly recommending that just so that it gives you a little bit of context as to what I'm doing, why I've done this, and what benefits it actually gives you. So yeah, timestamps will be included in this video as well, because it's probably going to take a while for me to get through all the content, and it's also there for people who express interest in only specific sections of the code. So if you don't really care so much about what the basic principles are, then you can just skip ahead to whatever little bit you'd actually be more interested in. Okay, so first things you'll probably notice if you've seen the previous video is that I now have a new background image, a new font style, a new color scheme, and I've also added a new section for my all-in-one water coolers information. So HWiNFO has a lot of sensors that pick up additional bits, which is why I chose to go with that route rather than the default Rainmeter sensors, so that I can display stuff like this, because the HWiNFO sensors are able to pick up information from my water cooler pretty easily. Now, all of this will be explained in the video later on as well, but the most important bit is that the code has basically stayed the same. The only thing that's really changed is the styling, and obviously I've added this new section here. So if I just open up Notepad real quick, another thing you may also have noticed is I've got quite a few tabs open in Notepad. Those tabs are all for other projects I've been looking into, and I've been doing some Raspberry Pi Pico coding a little bit, and I've got a little project on at the moment. If you guys are interested, I'll probably be doing a video about that later on as well. But for now, I'm just going to cover my Rainmeter sensor panel. So, getting into the code itself, first thing you'll see here is the Rainmeter section here. And as the comment here suggests, the Rainmeter section is just for general settings for the skin. So you've got the update timer here. This controls how many times, sorry, not how many times. This controls how long it takes before the skin will update everything. So the UI updates at the moment every 1000 milliseconds, which is once every second. The minimum value for the update setting is 16 milliseconds, but obviously the lower the value, the more often it'll try to poll for information and update your skin, which will obviously increase load and may look a bit jittery depending on how long you have to actually read what's been updated. So the background option here is used to specify an image to use as the background, As you can see here, the name of the file is new.jpg. The @ symbol between the two hashtags or pound symbols, depending on what you want to call them, is shorthand for the @resources folder, which is right here. So it's basically picking up whatever is in the same directory as the ini file. Anything with a prefix of @ you can just use this here, and then it will find it for you rather than having to type out an entire file name or a file location even. So that's that. The background mode setting or option dictates the behavior of the skin in relation to the background above it. So mode 0 basically says that the image dictates the spatial limits of the skin and how the background is displayed. In my case, the resolution of my image, if I just open up the resources here and hover over it, in my case the image is a resolution of 800 by 600. So if an element like this label goes out, if an element like this label goes outside of that resolution, then the element would just disappear as it's outside of the skin's limits. So like this label here, if it was outside of the resolution, it would just disappear. So yeah, that's basically what that is. Mode 1 is transparent background, so it's still sort of going by the same principle, only the image is transparent. Mode 2, just solid color, so it could just be solid black, solid white, whatever color you want. Mode 3 is basically scaling the image based on the background margin settings. Since mode 0 is the mode I'm using, the background margin setting is kind of irrelevant, so I'm not going to go over that. So next we got the metadata section here. Metadata is just additional information, doesn't have any effect on the code. It just consists of general info like the skin name, my name as the author. The information tab here just is a brief description, and you've also got the version number here if you're going to distribute your skin and create multiple versions of it. But since this is a personal project, I'm not really bothered with the distribution, so I'm just keeping it at version 1. Now the variable section, one of the more important sections to be fair. So what variables are, they're sections of memory that are used to store values for use in multiple places. So you don't have to repeat the same code multiple times over. The font name variable here stores the font name for all of the text elements on the skin, so if I wanted to switch to another font, I don't have to waste time looking for each reference of the text, since it uses the same variable everywhere. Same with text size small, it stores the sizes for use on whatever text you've got. Text size here is used for the headers, so like disk space, system usage, system temps, that sort of stuff. Text size small is more for other text content, so like you've got here the read write here, you've got the various numbers for storage space, everything like that. Color bar is the color for various bars used, so here's an example of the color bar there. So just for storage space, as well as the AIO dial also uses the color bar variable. Color bar background, let me try and say that in English again. Color bar background is pretty simple. It's just the background of the color bar, so once the color bar actually it overlaps the background right there. Color text, again, it's just color for the text, that's basically it. Now we got bar height here. Bar height basically just stores the value for the height of the progress bars. So if I just give you example of what would happen if I just change that to 10 from 4. If I refresh the skin, there you go, it increases the size of the bars quite a bit. So if I just put that back to 4 for now, refresh skin, there we go. Now these disk variables down here, they're just holding the IDs of the storage devices. So that's all of the general stuff out of the way. Now we're actually getting into the meat and potatoes of the project, if you will. So we got the measures here. So the measure section is where all the objects are defined to retrieve the data that I actually want to display. So measure CPU retrieves the CPU load using the default Rainmeter measure option of CPU and processor 0. So what processor 0 does is basically returns the CPU load between all of the cores, as it says here in the comment I've got. The measure RAM measure, if that really makes sense in English, measures RAM usage, again using the default Rainmeter physical memory measure option. So now we're on to the update divider option. Now this option basically acts as a kind of interrupter linked to the update setting that I previously pointed out back in the Rainmeter section. So basically what this means is it'll wait for the update timer to tick over a number of times. So in my case it'll wait for 5 updates before it'll actually go through and update the RAM measure, if that makes sense. So basically every 5 seconds it'll go and update whatever the value is the RAM has measured last time to whatever it is now. So this measure here returns GPU usage. This is different in the way that it uses the HWiNFO plugin to allow Rainmeter and HWiNFO to actually communicate with one another. So HWiNFO is the application that provides the information that Rainmeter can display. That's all done through the Rainmeter and HWiNFO plugin. So the plugin basically acts as a go-between for the 2 applications. So you've got Rainmeter as its own application, HWiNFO as its own application. The plugin acts as a go-between so that they can actually communicate with each other. So to explain the GPU measure, you have to have the measure option set to plugin because it's using the plugin to get the information. The rest of the options here are actually specific to HWiNFO. So the group, the HWiNFO sensor ID instance, the HWiNFO entry ID, and the HWiNFO type, they're all options specific to the HWiNFO plugin. So the plugin here is obviously defined as HWiNFO because that's what I want. And now we're down to the group option. So the group option tells the HWiNFO plugin that we want to access sensor information. So obviously I've got sensors here as the group option because I want to access the sensors to get my information. So if I just real quick open up the HWiNFO resources, the shared memory viewer. This is the tool that you use to actually find all of the sensor information that you need. So if I look here, the HWiNFO sensor ID at the moment is that. So if I go down to here, you'll notice here that the sensor ID here is equal to that. That basically tells the HWiNFO plugin that I just want all the sensor details from this little section here. So that's the sensor ID. the sensor instance just maps to whatever instance the sensor is currently using. So in this case it's 0x0 as per the sensor details here. So the HWiNFO entry ID here basically tells you which of these options that you want to actually take information from. So in my case, I believe it's core load. If I just check the ID, yep, and that ID is equal to that. And I want the current value. So at the moment, the current value is set to 13. If I just reload that and actually go back into it, core load is there. It's changed to 14, as you'd see. The units here basically say that it's currently in a percentage, so that it'd be a value from 0 to 100 in the current value. Maximum here basically just tells me the maximum percentage of load that I've actually reached today. And the average here is basically just says, well, what's the average load that's been used at this time. So that's pretty much that. Min value here has been set because obviously it's a percentage value. It needs to be set there because of the meter that we'll get onto later on. Max value, again, there's no point in not setting them, to be honest, because percentages can only really be a value from 0 to 100, so they have to be set in order to actually display percentages properly. The next measure, pretty much exactly the same, only we don't have a min and max value because it's not a percentage, it's an actual current value that I really want. Yep, GPU temperature, exactly the same. South bridge temperature, exactly the same. And the only real difference between all of these measures going on from the GPU usage is obviously the entry ID, the sensor ID, and everything like that. So now we're on to measure total disk. Right here we've got two measures to actually get all the information that I want. We've got free disk space here. Basically what it does is it just gets the information from disk 1 using the default Rainmeter measure option here, the free disk space measure. Specifying the drive is disk 1, so that would be my C drive as I showed previously up in the variable section. So the total flag here basically just tells me that I want to provide the total disk space. So the flag only has two options really, 0 for false and 1 for true. The default I believe is 0 at the moment, so that's why I had to set it to true. So if I remove that, it would basically just show the value of the disk space that has yet to be filled. So if I don't hit page up accidentally and actually hit home, I'll show you what happens when that is commented out. Refresh the skin. So that then will just default back to whatever I have as free space left, rather than what the full free space measurement is. So if I just do that and refresh, it's back to normal. So 475.9 gig is my total disk space, which is what I want displayed here. So the update divider is set to 120. Obviously that means it'll wait for 2 minutes or so before the value actually decides to update. Now the second measure here, the measure used disk 1, is very much the same, only it has this here invert measure option set. So instead of getting the value of space remaining or total space, it'll be inverting that measure, so it'll get the space used instead. So those measures are basically all the same for the rest of the disks, so I'm not really going to go over that. Now we've got disk 1 read here. Nothing really special or different here compared to the temperature meters I've previously mentioned, but obviously it's using different sensor IDs and it's just going off the current value. Again, copied that for all 3 of my disks. And the disk write speed, that's also basically the same. So continuing on to the next measures, I have here date and time measures. So using the default Rainmeter time measure, I was able to get the date and time and separate them into 2 different measures. So the difference between the 2 here is obviously the format. So because the measures have their own unique formats, it would basically be taking the same value from the time measure and displaying them differently. So format here is hours and minutes. As you can see here, it's just hours and minutes there. The measure date is in a format so that it's showing the day of the week, the day of the month it's currently on, as well as the month. Measure net in, pretty self-explanatory really, using the default net in measure from Rainmeter. Returns incoming network traffic as I specified here in this comment. Net out, exactly the same, only it's getting the outgoing network traffic. The AIO liquid temp, as previously mentioned, for the various other HWiNFO sensors that I've got. This is basically just grabbing the current value and displaying it here. I'll go over displaying it later on with the meters. So right now we're on the measure pump RPM. Again, that's exactly the same. It's just getting the current value of the pump's rotations per minute. Now we get to the pump RPM percentage. Now this is for the this here dial. Basically it's taking the minimum value and the maximum value that I found on the NZXT Kraken website. Basically just look at the specs for your pump and just set the min value and the max value accordingly, and it basically just automatically will set a percentage for all of this here goodness. This inverted one, I'm not actually sure is being used. Oh, it is, okay. Okay, yeah, it is being used. So, as previously mentioned, or not as previously mentioned, because it's not really inverted anymore. So I'm just going to remove that comment. Again, basically the exact same. Doesn't really need to be the exact same, I don't think. To be perfectly honest with you, I could probably just use this here, pump RPM for the meter, if I just set that to be that. And refresh that skin. Yeah, okay. Yeah, I don't really need that other RPM meter, I don't think. Measure even. So I just remove that, save that, refresh that, and everything's the same. Right, so now we're down to the styles section. So the styles, it shouldn't take too long to get through this. Styles are basically just predefined display attributes for use on different meters. So you can think of them as similar to variables, where you just reference them against any meters, and all meters using the same style reference would be effective if the styles were to change. So style title is currently used for title text. You can see here the alignment is set for center. Again, self-explanatory, centers the text. The case is forced to be uppercase here, so it's all capitalized. The string style is in bold, so it's got thicker lines around each character. Font color using the variable color text, as I previously mentioned, and same story with font face using the font name variable. Font size is fairly self-explanatory. Size of the font. Anti-aliasing is just a flag, an optional flag to enable edge smoothing. As you can see here, if I remove the line, it makes a big difference in quality. If I just refresh that, see, changed quite a bit. So if I just change that back here for the titles, especially down here, that you can see that's all jagged in that. So if I refresh that now, it's all back to normal and all nicely laid out. So ClipString here, down here, handles how the string behaves when it's within a meter. A meter is basically just the display element here. So 0 is the default value and basically means there's no clipping or wrapping at all. Value of 1 is enabled, so if a string exceeds the width and the height of the meter, an ellipsis would basically clip the text to show that there's more text than what's actually displayed. And when using multi-line text, the text will wrap first to fit as much text within the limits as it can, before clipping the rest of it with an ellipsis. So value 2 is automatic, so the meter itself will adjust to accommodate the text if no width or height values are set. Otherwise, if width and height value is set, then it would behave as if it was set to mode 1, as I've currently got it here. And that's basically it for all of the text styles. So the next thing I'll be going on to is the style bar style. Again, as you can see here, using the color bar variable to set the value of the bar color option. Bar orientation option is set to horizontal at the moment. I can actually flip that to be vertical if I just change this. So if I just change it to vertical, save that, you'll notice that the bar orientation here doesn't exactly make it very clear, but if I just increase the size of the bar a sec, let me just scroll all the way back up, bar height to 20, let's say, refresh skin. So you see here it's vertically scaling all the bar information. Now that's all you really need to know. So I change that to 4, go all the way back down so that I've got the style, and change that back to horizontal. Save that, refresh, and it's back to normal again. So solid color here basically just sets the background color of the bar, just to make sure that you've actually got it fully colored and that you can actually see a difference between usage and, you know, spare usage, if that makes sense. Probably just described that really horribly, but so obviously bar background here, the rest of the bar is colored in. This little sliver here is what's currently being used, which is color bar here, just to show that there's actually a difference, because otherwise you're not going to know whether or not it's actually scaling up along with the percentage. So now that the styles have been explained, we have the very final section now. This is the meters section. Now this is going to be quite a quite a long section because the meters are basically the visual elements in all of this. So they're used to take the measure values that we've got, the styles that we've got, and mash the two together to create a proper display element like what you can see here. So the first section we've got here is the meter that displays system usage. So that is this section all the way down to here. So meter title usage, this is a string meter. So the meter option here is basically set to string, so this says that this is literally just a text meter. The meter style option uses the previously defined style title is used here. X and Y are basically coordinates of where the meter should start from the top left corner of the skin. So X is the horizontal point, Y is the vertical point, and together they pinpoint the pixel to actually start displaying the meter. The W and H are the width and height values. So they're also pixel values. This basically just means that the meter is going to be 20 pixels high and 207 pixels wide, and that's literally it. So if I change the X value here, I'll give you a little example of what it actually changes. So previously it was 207, so if I change that to be 2 and refresh that, basically it's created all the way over here. So if I return that to 207, that'll move that along to the right again. If I increase it, it'll move it over to the right even more. So that's basically that. Y basically does the exact same. So if I move that to 2, it'll move up. If I put that to 302, it'll move down. Or it'll just disappear behind the network in meter. So if I just undo all of that, back to 207 and 20 and refresh the skin, and there we go, it's all back. So if I move that to 25, let's say, you'll notice it starts going down. So move that back to 20, refresh it, and it goes back up. So the text option literally just says, just as it says here, it's using system usage as the text. I can change that to be whatever I want as long as it's within the width parameter. So let's put a good old hello world. I meant Control S rather than S. So yeah, pretty self-explanatory on how to change meters and their current locations, what it actually says on them, so on and so forth. All of the that's pretty much the text meters covered. Literally, that's all you need to know for text meters. So now we're actually on to the value meters, the stuff that actually displays the value. So in this instance, I've got the measure CPU, so it's currently this here label. As you can see, it's updating various times whenever the update timer ticks around. Meter is set to be a string again because I want to display it as text. The meter style write text, so that's using that style here. The measure name is using the CPU measure as previously defined up at the top. The X value is currently set to 352, so that basically says to be 352 pixels along to the right. And you'll also notice here I've got OR as the Y value. Now what the OR value basically means is that it would take the previous meter's Y value and will adjust it 0 pixels down. So OR is basically shorthand for 44 as shown here. And it just keeps everything relative to the previous meter in case you want to group everything together. Or you can adjust it like so. So if I just put 10R, that would then basically take the same 44 value here and just move it down by 10 pixels. So if I refresh there, you see it's moved down 10 pixels. If I wanted to move it up, I'd do -10, for example, and it would move all the way back up the top. But I don't want to do that, so I'm going to remove that and basically make it back to OR. Refresh that and it's back to its original position. X you can do the exact same with. Obviously it would be using the using the same value as the meter above it, only obviously instead of moving up or down, it would be moving left or right depending on what you've currently got. So the last difference to really go over with the value meters is the text. So you'll notice here I've got a little %1 here. The only thing that's really important about the text is the %1 bit. That's basically telling the skin to grab whatever value the measure CPU currently has and display it as text. This additional % here is literally just additional text to go on to say that it's a percentage. So if I remove that, the only thing that's going to change is the percent's going to disappear. So if I put that back, that's basically what all meters are using to actually display values, is just that %1 there. So next we have the bar meter. So this bar meter refers to this bar underneath the CPU usage. So the meter has been set to be bar, funnily enough. Pretty self-explanatory there. Style, still using this style bar style as I previously went over. Measure name, it's using the same measure as the value of the CPU because it's a percentage. And bar height is obviously using the variable bar height to change its height, as I previously showed in the other examples. So if I just currently bar height is set to a value of 4, so if I was to set that to 10, save that, refresh, it would expand the bar to be 10 pixels high. Now obviously you'll notice that it hasn't changed any of the other bars, which is why I'm using the variable instead, because I want all of the bars to have the same styling. It's just to keep the same sort of schema going. So yep, that's pretty much it. So next we have got the meter label RAM. Again, that's just text, don't really need to go over that. Now meter value RAM, that's a bit of a difference here. So you'll notice here we've got this percentual option. This basically means it will go to the max and minimum value of the measure RAM meter to calculate the value as a percentage. So it will go from 0 to, in my case it's 32 gigabytes. And basically it will calculate automatically a percentage it's currently being used. Again, another bar. GPU usage, another text meter, text, just using the measure to display the text this time. all of this is basically the same. And now we're down to the temperature section. Again, basically the same. The only big difference that you'll really be seeing now is just the difference in coordinates. The X and Y and the width and height values are the only real differences at the moment, until I actually stop on something to explain something, that is. So, yep, that's another text meter there. Temperature current value. Now this is a little bit different, not really much, but is a little bit different. So we've got the same %1 value here as previously mentioned. That's just grabbing the measure value and putting that in as text. Now what you'll notice here is this strange little code between two square brackets and a C. Now what that is the Unicode value for the degree symbol. So for any weird text symbols you want, and you want to add it to text for a meter, you can put it within square brackets and then look up the Unicode value for it, and it'll automatically show you this here symbol. Whatever you put in, it'll translate it to actual text so that you can actually see it. And the next set of meter, yep, still nothing really different, it's just text. Now you'll notice one difference here, the left mouse up action. Now the left mouse up action basically says that it's basically telling the skin that on mouse up, so when you click your mouse button, that's mouse down. When you release the mouse button to release the click, that's mouse up. So upon that event being recorded, it's basically saying do something whenever you click something. In my case, all it does is open disk 1. It opens the root of disk 1. That's all it does. So if I click on here, it automatically opens up to my local disk. Now I've got that repeated for all of my disks, I believe. Yep, SSD storage, N drive is my mass storage. And yeah, that's basically the left mouse up action option set. Nothing really different there, to be honest. Next meter is also slightly different because you can see it's using two measures here instead of just the one. So to display the values of two different measures, it's quite simple. You'll recognize the %1 from earlier. The %1 is obviously just taking measure 1's value. Now what you'll also notice here is %2. %2, funnily enough, the value for measure 2. And you can basically just repeat that for that format for however many measures you want to have within a meter. The B character there is just added on by me to make sure that it's clear that it's actually in gigabytes, since the measure returns the value, it returns a text value of the actual numeric value of the size, as well as just a G appended to it at the end. So I've just added the capital B just to make sure that it's obvious that it's in gigabytes. Autoscale scales the measure values to specific formats. So by default the measures provide the value in bytes, but I want gigabytes. So the value needs to be set to 1, since that value specifies that we're dividing bytes by 1024. Autoscale automatically uses the highest unit available as well. So if I were to use up 411 gig, well, 415 now, it was 411 at the time I was actually writing this script, of my C drives, it will then display megabytes instead. So as an example of this, you can actually see on the N drive I've got 771.8 gigabytes remaining of a 1.8 terabyte drive. That's showing gigabytes because obviously I haven't gone over a terabyte yet, and that's obviously showing terabytes because it's a terabyte drive. So that pretty much concludes the disk space section. Now we're on to the disk read and write values next, which is disk usage down here. So you've obviously got your text meters again, text meter again, and now you've got the actual read activity here. So really the only difference down here that I've not really gone over yet is the number of decimals option. So if you've got a numeric value you want to display as text, you can also add a number of decimals option down here. Pretty self-explanatory really. It just writes whatever text you've got accurate to 3 decimal places. You can obviously have more or less if you want. I just prefer to have 3 decimal places because it just uses up a bit of space. Doesn't make it look cluttered, it just looks quite nice. It's the only reason why I wanted it accurate to 3 decimal places. And that's pretty much it for the read and write activity. Just copy and paste it as you go for however many drives you got. Now we're on to the network usage. Again, typical text, auto scale set to 1K, which basically means that I want it shown in values of 1000 rather than the binary value of 1024. And yep, it's just in. So the default current value for this basically already adds the kilobytes bit, or kilobits even. I just added the B/S on the end of it just to make it obvious that it's kilobits. So now we've got a new meter to go over. This is called the line meter. It's a line graph basically. The meter has to be set to line so that it knows what we actually want to display. Line count here shows the number of lines you want to actually show on the grid. Line color, again, simply the color of the line. Solid color, the background color. So if I wanted a dark red, I'd just change it to be, for example, 255.0.0.255. So if I just refresh that, you notice it's gone quite bright red. And the fourth value, I don't think I've gone over the fourth value of the color section yet. The fourth value basically is transparency. So if I wanted to be less transparent, I'd just set it to be 100, for example, and refresh. So you'll notice it's gone quite transparent now. Actually, now that I'm thinking about it, let's change it to be a little bit more matching to the color scheme. So if I set the solid color to be bar, no, it wasn't bar, was it? It was color bar background. If I set the line color to be color bar, save that, refresh that, see what that looks like. Okay, that looks better. Yeah, that looks better. So I'm just going to copy that, paste that down here for the out as well. Refresh that. That looks way better now. Looks like it actually matches with all of the rest of it. So yeah, again, for the clock, it's just displaying what the measure time value has. Measure date, exactly the same. So we've got typical text, typical text, typical text, typical text. Now we've got the round line meter. So basically what the round line meter is just a line meter that is round, funnily enough. So going through the options we have for the round line meter, we have the line length here. Pretty self-explanatory. It's the length of the line in pixels. Line start is the distance the line starts from the center of rotation, so it basically controls how close the arc is to the point of rotation, if that makes sense. Now, start angle is very important to get right as well if you want to display the meter correctly and ensure the bar fills up in the correct direction. In my case, I want a semicircular bar to display the pump speed. So I have 180 degrees as a constant. Since a circle is 360 degrees, half of that, 180. Now I need to convert that into radians, which is the unit used for the start angle option. So you can use a radian converter through Google, or you can use the calculation degrees multiplied by pi divided by 180 to get the ideal value for you. In my case, I would take 180 degrees as it's my constant, multiply it by 3.14159, and then divide it by 180. Funnily enough, that just equaled the value of pi. So I'm just keeping 3.14159 as my start angle. Now, rotation angle also uses the radians value, as previously mentioned in the start angle explanation. This option here is also very important, as it controls the size of the angle of rotation for the meter, which easily enough is going to be pi again. So that's the value of 180 degrees in radians. And yep, so that's basically done over twice, so that I've got the background here as color background. It's just the full half circle. And we've got here the pump speed, which goes on top of the background, using the measure pump RPM percentage measure. So that basically, adding the measure name here basically says that I want to adjust the line meter by this value. No, that's all it really does. So you'll see it jumping up and down every now and again whenever the pump actually starts to pick stuff up. Yeah, that's basically it. The only other thing to go over is this, but this is just a typical text meter. Again, it's literally just showing the RPM of the pump. So I hope that helped out anyone who was stuck on their own Rainmeter project, or at very least inspired others to try their hand in coding one themselves. Rainmeter is pretty much the one tool that I've used that inspired me to actually go into software development as a full-time job, which I've been doing now for the last 5 years. So as of this recording, obviously, I've been doing it for 5 years. So the next video I'll be working on is another personal project of mine involving a Raspberry Pi Pico microcontroller. I've got the proof of concept more or less working now. I just have to print out some 3D print out some parts for testing. So that's pretty much everything from me, and I hope I'll see you guys in the next video.